Thanks for joining me today in the garage, you guys. Welcome back. I'm going to take a quick minute today and really, I don't know what quick really describes it because it's going to take a bit to explain. But talk a little bit about the layout on my bows, specifically speaking of the bamboo backed Ipe reflex deflex build that I did earlier this year. I've been fielding a lot of questions over time about layout. And the layout of these bows it's a pretty simple layout. So it's basically an American flat bow. As I run a consistent width right through the grip area, run an additional 4 inches or so out into the limb, and then taper down to my tips. Okay, so that is the layout. Specific measurements are going to depend on the materials that you use, and so that's kind of what I'm going to address today. Is how we can apply this to different materials and make it work for you in your build and what materials you have available to you. Okay, so lots of information to dive into. Guys, building bows and building effective bows, let's say, is really just an adventure in trade-off. Okay, every design aspect that you employ in a bow has some sort of trade-off elsewhere within the build of that bow, whether it be in length, width. You could trade off even draw weight for in some instances. You can gain draw weight with different things that you do, but you have other trade-offs involved in doing those things. So we're going to cover a lot of those aspects here. It is a ton to uncover, unwrap, and talk about. So I'm going to go very, very lightly, okay, into bow design because the design has already been determined here. Like I said, this is going to relate specifically to my reflex deflex laminated bows. And when I say laminated, I mean one glue line. There's a back and there's a belly, okay? It's the most efficient design that I have uncovered. The more glue lines, the less efficient it gets. But here again, we're talking trade-offs because you can get better, more stable limbs in those instances. So the trade-offs abound. And guys, we could talk about all the trade-offs and different ways to design a bow for hours on end. And I don't want to do that. What I want to do is really kind of keep my discussion to specifically what's being asked with regard to the bow, like my Ipe and bamboo back build that I did earlier in the year. So I'm going to cut it from here and we'll dive into some of the more specifics as far as what to consider if you want to change materials and still do the build. All right, hang in there. Here we go. I have tried to shoot this portion of the video on so many different occasions now. I want to say probably 4 or 5 times because I continually get off the topic of just a bamboo backed reflex deflex bow design. You cannot address bow construction without really getting mired up in the whole design piece of things. There's so many different aspects to address, and as I discussed before, the trade-offs really start to murky up the water for us. So I'm taking another attempt here to really keep things on point specific to bamboo backing. All right, so here we go. Our number one concern, at least when I'm making a bow, my number one concern or design aspect or constraint, if that's what you want to call it, is the length of the bow. So there's a lot of different things that play into the consideration for length. One can be the length of the stave or board that you're dealing with because you can't build a bow longer than the piece you have in your hands. Secondly would be your personal preference of the length of the bow that you want to make. And then, of course, a lot of what's going to dictate those two things is the environment in which you're going to use the bow. So let's take an extreme case. If you're going to be shooting this bow from the back of a horse, it needs to be an incredibly short bow. If you are target shooting, then length probably is not of major concern to you. If you're hunting and you're going to be out in the woods or in thick brush or something along those lines, then you probably want to have a bow that is on the shorter side. Maybe not recurved because you get a lot of the brush and stuff stuck between your string and the limb of the bow. So lots of things to consider there. But length is where we start. Okay, so there you go. Length, first constraint. Secondly is then, you know, the properties you want that bow to have. Draw weight, draw length, those sorts of things, which will also kind of fall into or be a part of the trade-off of the length of the stave you're dealing with. You might not be able to get a 28-inch draw out of a 50-inch stave if that's what you have. If that's what you're working with and those are the two criteria you want to meet, then you're going to have to design your bow such that it's going to be able to handle those two criteria. In this instance, we're dealing with a bamboo-backed bow, straight-limbed bow, bamboo back, and the belly material being that of the question. That's going to be our trade-off piece for the purposes of this discussion. Okay, so I want to get a couple things straight so that while we're speaking about the properties of these bows, I've got two of them right in front of me. You can see I got a hickory backed with bamboo. I got a ipe backed with bamboo. But when we're talking about wide and narrow, so we got to be able to draw these distinctions. So this is going to be the width of the bow, side to side, wide, narrow. Okay, and then when we talk about thick and thin, we're talking about back to belly, thick and thin. Okay, so that's kind of how we're going to approach this discussion so that we can all be on the same page and not get confused between thin, thick, narrow, wide. Okay. Okay, so there is that initial introduction. So the question that I'm specifically fielding is making a bamboo back bow with a second string bowwood. What would be considered a second string bowwood or whitewood bowwood? The oaks, maple, ash, elm, that sort of thing. I would not necessarily include hickory in with the whitewoods, even though I want to say most bowyers consider hickory to be a whitewood bow or second string bow wood, but hickory can be thinner, take that back, narrower than pretty much any other whitewood bow. So it can still handle narrow dimensions and safely handle the workload of a bow. So it's kind of that transitional wood, in my opinion. It handles bamboo very well and can make a pretty narrow bow, kind of along the lines of ipe. So that having been said, so let's kind of talk about second string bow woods in comparison to your typical bow woods like yew or Osage orange. The way you make a whitewood bow match the performance of a typical bow wood is to make the dimensions just a little larger, and specifically the limbs a little bit wider. So you can still make shorter bows, just got to make wider limbs, because the wider limb will accommodate a thinner limb, thinner back to belly if it's wider, and that way your wood will safely bend to a greater degree without breaking. It increases tension safety in addition to compression safety on a whitewood bow that is normally enjoyed by a narrower, similar piece of, like I said, bow woods, Osage or yew or something like that. So now where we run into our problem is with a bamboo back, because bamboo backing does not follow the rules when it comes to narrow and wide limbs. And so I'm going to take us over here to a little diagram that I drew up. And let's talk about the paradox of bamboo. Okay, bamboo is, it becomes a design constraint, is what this represents. Okay, so here's like the cross section of bamboo. All right, got a couple pieces Here, there's like a cross section similar to that one. You'll run into pieces of bamboo that look a lot like this too. Okay, so there's your typical bamboo cross sections of anything that you purchase that you're going to be backing a bow with. All right. Bamboo is an incredibly tension. I don't want to say tension safe. It will compress the belly piece of wood more so than any other backing that you can put on a bow. Okay, so it is incredibly strong in tension, and for that reason, you have to have a proportionately thicker belly piece of wood and built into that thickness to withstand the compression that is imparted by bamboo. Okay, so we come down now to the ratio that the bamboo resides in that total thickness of the limb. And so I've kind of drawn out some different examples right here. Okay, so 1 to 4, 1 to 5, where your bamboo is only about 20% of the limb thickness. Okay, this is your best scenario for, let's say, like a white wood bow. You need a lot of meat here to stand up to that bamboo, and so the bamboo needs to be really thin. When you get into like the 1 to 2, 1 to 3 range right here, where it's taking up 1/4 to 1/3 of your limb, this is where you need a very stout belly piece that is going to really stand up to the compressive properties of bamboo. All right, so this is going to be pretty tough on a belly. You get down into this range where it occupies almost half of the thickness of the limb, okay, where your ratio is 1 to 1 or 1 to 2 right here. This is a scenario that is almost impossible for a belly to handle. Okay, this belly, if it's a whitewood, is certainly going to crush, and this scenario will crush just about anything. And I would say about the only piece of wood that's going to stand up to this with any reasonable expectation is probably ipe, and even then you're pushing it to the brink. Okay, so this is a very difficult ratio to deal with. Now on the next side over, I'm going to kind of show the paradox of bamboo. So with a whitewood, you want to be as wide as possible, or you want to make your limbs wider to accommodate the compressive nature of the backing. The problem is when you go wider with bamboo, you end up with the thickest piece, right? So a wide cut of bamboo results in this cross section. A thinner strip of bamboo ends up in this cross section, and the very narrowest cut of bamboo on that crown results in the thinnest application. And so what happens is the more narrow your piece of bamboo, the more forgiving it is in terms of its compressive forces on that belly piece. And the wider your bamboo is, the more formidable it becomes on the belly, which means it kind of negates the opportunity of going wide-limbed on your bow. So you cannot go wider with bamboo. And I struck a line on this piece right here. That's 2 inches across right here. And that bamboo is thick. You know, I mean, that's at the thinnest that you can get a 2-inch piece of bamboo out of this particular piece of bamboo. And this is typical of what you would get when you're ordering backing pieces. You're not in much better shape with this piece either. It's just, it's too much thickness in proportion to your limb, because a wide limb for like a whitewood bow is for the purposes of getting it thinner front to back so that it bends easier. Well, that's where bamboo works slow torture on that belly. And so now we got to start looking at this and talking about, well, how do we solve that problem? Here's a couple of things, couple of diagrams of ways that we can solve that problem. just in a straight limbed application. One would be trapping the bow, right? And so what we do is we continue to have a really wide belly. So we have a lot of belly wood involved in combating the compression of the bamboo. Well, what we can do is then get a thinner ratio of bamboo to, or back to belly piece with that bamboo by introducing a trapezoidal cross section. So this is one way that we can do that. The other way to do that would be decrowning the backing strip on your bow and creating a cross section like this, and you can kind of see here, put in like a dotted line of where the original crown would have been, and then you flatten it out. Now I'll probably run into a little bit of resistance to this process, because of course you're flattening out the nodes in that instance, and there are a contingent of bowyers out there that would tell you that thinning down those nodes creates a weak spot in your backing and you run the risk of the bow splintering and etc. I would tell you I have done this process, and as a matter of fact, this particular bow is it. I don't know if you can tell, but that node is gone. That node is gone. It's flattened out. So I flattened the bamboo, or decrowned this bamboo on this particular bow, and it is of course my whitewood bow. Now that's the only bow I've done that to. I actually did that out of desperation. It lifted a splinter on the high crown of the backing, and so I decrowned it. I lost a little weight. It turned out to be a 50-pound bow, but it was drawing 65 at 28 inches when it lifted that splinter. So I lost a lot of weight in the process of decrowning. Again, a trade-off, you know, for safety. So there's kind of the paradox of bamboo. The wider it gets, the thicker it gets, the more formidable it gets on your belly. It all kind of works in opposite of what you're hoping to accomplish with a whitewood bow. So then the question continues to be, outside of these two processes, what other things can we do to then create safety within the limbs of those bows? One notable thing to do would be to deflex the bow through the middle. All right, so when you introduce deflex into your bow, your belly wood or your limbs are already flexing toward the string without ever experiencing any compression on that belly yet. Okay, now we combat that then with a reflex. Okay, and that reflex is going to introduce a little more strain in that area. However, with the way we're constructing this with the Perry reflex methodology, when we glue the backing on and induce that reflex, okay, when that reflex pulls out straight, it is building weight, but it is not introducing any compression yet on that belly wood. So this design lends itself very well to mitigating a lot of the compressive forces of bamboo. The question is, can it work well enough to use on something like maple or oak or ash or something like that? And my answer to that would be, in these dimensions, all of those second string woods I just mentioned would fail. So it needs to be a smidgen wider. So we got to find a piece of bamboo that either has a real large diameter so that the crown is not so high in the center, and or employ the two methods like I described here. Okay, or we make the bow a little bit longer, right? So you can go a little longer and make the limbs a little narrower, and that way you can get the safety of a longer draw, okay, out of a thinner or out of a narrower limbed bow on a whitewood. All right, so those are kind of the answers to the question that was asked of me, and I realize this video is still running long, even though I'm staying on point as best as I know how. I will probably do another video just in terms of some basic design elements and truthfully how hickory can solve a lot of these issues, because there's, generally speaking, no crown associated with hickory, and all of the conversation we just had about the wider backing strip becoming thicker go out the window with the use of hickory. So a little teaser there for the opportunities that you create by changing that backing strip. So guys, thanks for tuning in. Like and subscribe if you would, and I will talk to you next week.